Matter. Matter is any substance that occupies space and has a mass. Matter is the stuff that is used to make this universe. Matter is made from atoms and molecules. Matter can be classified mainly into two. See, matter, mixtures and pure substances or substances. You know, mixtures are formed by the combination of or by mixing two or more components. See, there are two types of mixtures, namely homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures are obtained by the mixing of two or more components so that the mixing components cannot be identified after mixing. They become almost homogeneous, alike. For example, when we put some sugar into water to get a sugar solution, we cannot identify sugar and water separately after mixing, after making a solution. So we get a homogeneous mixture. See, air around us is a homogeneous mixture of many gases. So air is a homogeneous mixture. Now, what is heterogeneous mixture? A heterogeneous mixture is obtained by mixing two or more components or two or more substances so that the mixing components can be identified even after mixing. The components can be distinguished after mixing. For example, when we mix some kerosene and water, we can separately see kerosene and water. We can identify both kerosene and water. If we mix some sand and salt together, then we can identify sand and salt separately after mixing. They are called heterogeneous mixtures. Now, what about pure substances? See, pure substances can be further classified into two. They are elements and compounds. Elements and compounds. Elements and compounds. See, elements can be split up into only one kind of substance, but compound can be split up into different type of substances. And you know that this is hydrogen, helium, sodium, such elements. Then compounds, calcium oxide, carbon dioxide, methane, etc. So methane can be split up into carbon and hydrogen. But hydrogen cannot be split up into different substances. Okay, that are pure substances. So pure substances are classified into elements and compounds. Based on physical properties, physical state, matter can be classified into different types, different forms. There are about 6 to 12 different states of matter, scientists say. Among them, 3 important classic examples are solids, liquids and gases. Solids, liquids and gases. Now what about solids? In solids, the particles are very closely packed. Particles are very closely packed. They have definite shape and volume. They are incompressible. They cannot be compressed. They are incompressible. They cannot be compressed. Liquids. See, in liquids, the constituents are not so closely packed as in solids, somewhat loosely packed. They are not so closely packed. Not closely packed. Not so closely packed. They do not have definite shape. They do not have definite shape. They assumes the shape of the containing vessel. They assumes the shape of containing vessel. They assumes the shape of the container or containing vessel. But they have definite volume. They have definite volume. They are compressible only to a small extent. Small extent. They are compressible only to a small extent. Now, what about gases? In gases, the particles are loosely packed. Loosely packed. Very loosely packed. And they do not have definite shape and volume. They do not have definite shape and volume. They are highly compressible. They are highly compressible. That about the three main states of matter, that is solids, liquids and gases. Mass and weight. Mass of a substance is defined as the quantity of matter or amount of matter present in the substance. That is what is called a mass. Mass can be accurately determined using a chemical balance or analytical balance. And the SI unit or System International Unit of Mass is kilograms. Kilogram. And you know that 1 kilogram is equal to 1000 grams. 1000 grams or 10 raised to 3 grams. 1 kilogram is equal to 1000 grams or 10 raised to 3 grams. Now, what is weight? Weight of a substance is defined as the force of gravity exerted on it. The force of gravity exerted on a substance is called weight. It may change from place to place. Temperature. Usually temperature is expressed in degree Celsius, degree Fahrenheit and in Kelvin scale. Degree Celsius and degree Fahrenheit are related by the expression degree Fahrenheit is equal to degree Celsius into 9 by 5 plus 32. That is, if we want to convert degree Celsius into degree Fahrenheit, then we have to multiply that degree Celsius with 9 by 5 and then add 32. Okay. See, if we want to convert degree Fahrenheit into degree Celsius, now we can rearrange this formula. That is, degree Celsius into 9 by 5 is equal to degree Fahrenheit minus 32. Minus 32. So, degree Celsius is equal to degree Fahrenheit minus 32 into this 5 by 9. And this formula can be used to convert degree Fahrenheit into degree Celsius. This formula can be used to convert degree Celsius into degree Fahrenheit. Okay. In Kelvin scale, temperature in degrees Celsius plus 273.15. So temperature in Kelvin scale is equal to temperature in degrees Celsius plus 273.15. Therefore, temperature in degrees Celsius is equal to temperature in Kelvin minus 273.15. See, this is the conversion of temperature from degree Celsius to Kelvin scale and Kelvin scale to degree Celsius. Okay. For example, how will you convert 30 degrees Celsius into degree Fahrenheit? See, we can convert 30 degrees Celsius according to this formula, that is 30 into 9 by 5 plus 32. That is equal to temperature in Fahrenheit, degree Fahrenheit. That is equal to 30 into 9 by 5 plus 32. That is 30 into 1.8 plus 32. That is 30 into 1.8 is 54 plus 32. That is equal to 86. So temperature in Fahrenheit is equal to 86. So we can say that 30 degrees Celsius is equal to 86 degree Fahrenheit. 86 degree Fahrenheit. Two large and two small quantities can be expressed in terms of scientific notation. Scientific notation. Scientific notation. See, the scientific notation is abbreviated as, or it is expressed as capital N into 10 raised to small n. Capital N into 10 raised to small n, where small n is the power raised to 10. Power raised to 10. And n is a number with a non-zero digit to the left of the decimal point. N is a number with a non-zero digit to the left of the decimal point. That is, n takes the value between 1.00 to 9.0999. 1.00 to 9.999. N takes the value between. For example, see, Avogadro's number, Avogadro's number is Na is equal to 6.022 into 10 raised to 23. It can be expressed as, see, if we take 110 and multiply it with this, we get 60.22 into 10 raised to 22. Now, if we remove 110 from here, that is, it becomes 0.6022 into 110 comes here into 10. So we get 10 raised to 24. See, all these values are correct, but this value is in scientific notation. These values are not in scientific notations. So scientific notation, in scientific notation, the figure or the value or the number stands in the place of n must contain one non-zero digit to the left of the decimal point. See, this is the decimal point. To the left of that decimal point, there is a non-zero digit 6. Here there are two digits. Here there is no digit, that is 0. So this is acceptable, and this is in the form of scientific notation in scientific calculations, in physics, chemistry, and in every types of science. We use scientific notations to express two large and two small quantities. We are going to learn two terms, namely accuracy and precision. Accuracy is the closeness of the measured value to that of the true value. So, for knowing accuracy, the true value must be known, because we have to compare the observed value with the true value. Whereas precision is the closeness among the replicate measurements made for the same sample. Since we check only the closeness among the replicated measurements, true value is not necessary for precision. So we are going to learn two terms, accuracy and precision. Two students were supplied with a 10 milliliter of ferrous sulfate solution for analysis. 10 milliliter contain 0.76 gram ferrous sulfate. They are asked to find the mass of ferrous sulfate in 10 ml each of the solution by a particular experiment, like a titration. First student got the result as 0.761 and the second student got the result as 0.701. See, from these two observed values, it is clear that the observed value by the first student is more close to the true value. This is the true value. So the result obtained by the first student is more accurate. But the result obtained by the second student is not quite close to the true value, so it is less accurate. So it's clear that accuracy is the closeness of the observed value to that of the true value. Now, we can check the term precision by an example. The same solution were given to two students, first and second students, and asked to repeat the experiment twice. See, first student got two results, that is 0.761 and 0.761, that is the same answer is repeated. The same value is repeated by repeating the experiment. Second student got two values as 0.751 and 0.762. See, the values obtained by the first student are the same, that is, they are quite close. But the values obtained by the second student are different. From this, it is clear that the observed values by the first student are more precise and observed value by the second student are less precise. In short, these two values are more accurate and more precise. See, they are quite close to 0.76, so they are more accurate and they are closer to one another, so they are more precise. But the results obtained by the second student are less accurate. They are different from the true value and they are different between themselves, so they are less precise. The values obtained by the second student are less precise and less accurate. That's all.